Imagine this scenario. A recent bootcamp student shared this story with us, and honestly, it is a total rite of passage for almost anyone working in software deployment. They spent weeks grinding on a grueling project. They built a Docker image, tested it locally on their laptop, and it was absolutely beautiful. Everything worked flawlessly, exactly as it was supposed to. So, riding that high, they pushed it to production with total confidence. And then, the container crashed on startup. Just a total, immediate failure. It's that classic mystery that leaves developers staring at their screens in absolute disbelief. So, what exactly happened here? Let's unpack it. Here is the craziest part of the whole story. They didn't change a single thing. The artifact they pushed to the server was the exact same image they were running locally. Literally not a single binary difference. And because it was the exact same image, it was, of course, the exact same code. Not a single line was modified, not a character, not a config file inside the app, not even a blank space was altered between that local testing environment and the production server. To build that image, they used the exact same Docker file. The build instructions were completely identical, step for step, layer for layer. There was absolutely no divergence in how this application was packaged up. But somehow, despite everything being perfectly identical, they got a completely different result, a perfectly seamless local experience, and a crashing production deployment. So here is the big question. If everything inside that container is exactly the same, why did the deploy fail so spectacularly? Section 1. The Run Anywhere Myth. Okay, let's dive into this, because this specific scenario trips up everyone from absolute beginners to highly seasoned engineers. It all really stems from Docker's famous marketing slogan, "Build once, run anywhere." Now, this statement isn't exactly a lie, but it is deeply, deeply misunderstood. That promise is completely true for the code inside the image. The code is packaged up, it's locked in, and it's ready to go. But if you're relying entirely on that slogan, you are missing a massive piece of the deployment puzzle. That missing piece is what we're going to call the environment gap. This refers to absolutely everything happening around the container once it leaves your laptop. When Docker says run anywhere, we have to remember that the image itself is completely blind to its surroundings. It's basically a sealed box. It has absolutely no way of knowing that the host environment outside of its little bubble has drastically changed between your local machine and your production server. Section 2. 3 silent environment killers. So if the image didn't break, what did? Let's do a quick autopsy of this crime scene and explore the 3 specific things that actually broke that student's deployment, and honestly break deployments all over the world every single day. Killer number 1 is user permissions. Locally, the student's container ran as the root user. Because it was root, it could write log files wherever it wanted on the system without a single complaint. It had ultimate power. But in production, the security setup ran containers as a non-root user. Now, this isn't a mistake. This is standard practice to limit what a compromised container can do if someone malicious gets inside. So when the app booted up in production, it tried to write to a directory it now had 0 permission to touch. The result? It went down immediately. There was nothing wrong with the image, but the environment around it was totally different. Killer number 2, environment variables. This same story shows up constantly. Locally, you're probably loading a simple .env file packed with API keys, database URLs, feature flags, whatever the app needs to function. But that file usually isn't part of the image itself, and it absolutely shouldn't be. You never want your secret passwords baked into something you're pushing to a registry. In production, those values have to come from somewhere else entirely, like a secrets manager or injected config maps. If you miss just one of those during deployment, the app either crashes violently on startup, or honestly even worse, it fails quietly the very first time it tries to use a key that simply isn't there. And killer number 3, it's file permissions on mounted volumes. And this brilliantly illustrates a fundamental truth about how containers interact with host machines. You see, a container might read and write to a mounted volume just fine on your local machine, but then hit a hard permission denied error in production. Why? Because the host directory it's mounted to belongs to an entirely different user ID on the server than it did on your laptop. Docker doesn't magically translate those permissions for you, it fully expects you to manage them. Section 3. It's not a Docker flaw. Hearing all this, it's super easy to get frustrated and just blame the technology. But it is critical to understand that none of this is a Docker flaw. Docker is doing exactly what it's told to do. It runs what you told it to run with whatever access it was actually given by the surrounding system. Let's look at this whole operational matrix. Locally, you've got root access, a handy .env file for variables, and perfectly matching user IDs for your volumes. It's a cozy, frictionless environment. In production, however, you're locked down to non-root for security, you're totally reliant on a secrets manager for variables, and you're dealing with mismatched user IDs for those volumes. The image is exactly the same everywhere, but the user running it, the permissions it has, and the secrets it can reach, yeah, none of that travels with the image automatically.
Section 4. Fixing the environment gap.
So the crucial point is, how do we bridge this gap? We've diagnosed the problem, and the fix isn't actually that complicated once you know what to look for, and accept that the environment is your responsibility. Here are 3 concrete steps you can take to catch these issues on your laptop before a production server ever sees them. First, run your container as a non-root user locally too. By simulating that restricted environment early, you catch those write permission issues way before you deploy. Second, keep a clear, strict list of every single environment variable your application needs and diligently check it against what's actually configured in each environment. Don't just assume they match, verify them. And third, test with volumes and permissions that mirror your production setup as closely as you possibly can, instead of blindly assuming a container will just behave the same everywhere. Docker solved a massive, real-world problem by standardizing how we package code. It is an incredible piece of technology. It just didn't solve the problem people naturally assume it solved, which is managing the complex environment around the code. You still have to manage that. So as we wrap up this explainer, I'll leave you with this question to think about for your own projects. Docker solved a real problem, but are you solving the right one in your deployments? Make sure you're minding the gap. Thanks for joining me, and I hope this helps you take total control of your next deployment.